Hello students, good morning students. In previous video, I already explained you Bohr model and its applications. Which applications I explained? Energy, radius, velocity, formulas based for applications I explained. Formulas based applications I explained. Now, hydrogen spectrum of Bohr model. What is hydrogen spectrum? Why it is came? And what is this spectral lines? These are called as spectral lines. Simply, students, these spectral lines are nothing but electron energy levels. Electron is moving from one orbit to another orbit. It is again moving, go back to the ground state. Different spectral lines observed. Bohr. That is the hydrogen spectrum. This spectral lines observation is only for hydrogen like spaces. That means only one electron spaces, simply, not more than one electron spaces. Remember this. Hydrogen spectrum is applicable for one electron spaces, not for more than one electron spaces. How this spectrum is came? Once I will explain. Look at here, the meaning of the spectrum. The meaning of the spectrum is nothing but splitting of spectral lines into different colors. Splitting of spectral lines. Here, this is the discharge tube. Beside the discharge tube, slits are present. Here, prism is present and photographic plate is present. Photographic film or photographic plate. Inside the discharge tube, hydrogen gas is present. Before filling the hydrogen gas, the discharge tube create a vacuum, then filling with hydrogen gas. The discharge tube is connected with electrical discharge. That means electrical circuit, electrical current. Anode and cathode end. After supplying the electrical current to the discharge tube, inside that what is present? H2 gas is present. That H2 gas simply split into hydrogen atoms. Hydrogen atoms. Split into hydrogen atoms means before supplying the electricity, the H2 gas is present in ground state. After supplying the electricity between the hydrogen atoms, what is present? Single bond is present. That bond is breaking. That bond is breaking and hydrogen individual atoms are generating. So they are present in higher energy level. Simple meaning, higher energy level. That hydrogen gas rays are moving towards the slits and reaches the prism. After reaching the prism, in the photographic plate, Bohr observed different colors. Why the different colors are appears? What is the reason? Simply I am telling here. Hydrogen gas is present. That hydrogen gas is splits into hydrogen atoms. Every hydrogen gas doesn't accept same amount of energy. That one molecule of hydrogen absorbs different energy. Another molecule of hydrogen absorbs different energy. Another molecule of hydrogen absorbs different energy. Absorbs different energy means the hydrogen atoms, after absorbing this hydrogen gas energy, the hydrogen atoms moves to different energy levels. They again want to come back to the ground state. In that case, we are observing the spectral lines. So this is simply called as hydrogen spectrum. Hydrogen spectrum, it is a emission spectrum. Why it is called as emission spectrum? Hydrogen H2 absorbs the energy. The electrons are moved to higher energy levels. They again want to go back to the ground state. Like this, different energy levels. So we are observing the lines, that emission lines. Simply, it is called as emission spectrum. These are emission spectral lines. So Bohr and his co-workers observed this hydrogen spectrum. By honor of them, different spectral lines gave different names simply. For example, if an electron is present, hydrogen is present at ground state, it is moved to the different energy levels. Different energy levels again want to go back to the ground state. All different energy levels of hydrogen atom of electron go back to the ground state. That is, series is observed by Lyman. That series is called as Lyman. That Lyman series is observed in the UV region. Simply, Lyman series. What is the next series? The electron is present in the different energy levels, go back to the ground level, but not n is equal to 1, n is equal to 2. If it is comes to the n is equal to 2, that series is called as Balmer series. That is observed in the visible region. Next, electron from the higher energy level, it is want to go back to the third energy level, that is Paschen series. That spectral line is observed in the region of near IR. Next, bracket. Electron is coming from higher energy level to fourth orbit, that is bracket series. Electron is coming from higher orbit to fifth orbit, that is called as Fund series. Lyman, Balmer, Paschen, bracket, Fund and Humphrey. All these spectral lines, they are simply electron is coming from higher energy level to lower energy level. Higher energy level to lower energy level means the electron is releasing energy in the form of emission, simply emission spectrum. So this students, this spectral lines region is important. Lyman series, Balmer series, Paschen series, bracket, Fund observed in the which region, that point is important. And one more point in the problems point of view, n is equal to 1, that is ground state. N is equal to 1, that is second orbit. That second orbit is nothing but electron is moving from here to here, that is excitation. That is which excitation? First excitation. First excited state means n is equal to 2. Electron is moving from n is equal to 1 to n is equal to 3. That is third orbit. Third orbit is nothing but second excited state. Second excited state is nothing but third orbit. Third excited state is nothing but fourth orbit. Don't confuse with the excited state and orbits. This is the problem's point of view. This terminology is important. First excited state, second orbit. Second excited state, third orbit. Third excited state, fourth orbit. Next, in the every series, students, this is the first line. In the every series, this is first line. This is first line. Here the first line. Here the first line. Every series, the first line is represented with H alpha. Next, second line is represented, that is second line. Second line is represented with H beta. Next, third line is represented with H gamma. Third line. So in the every series, first line is H alpha, second line is H beta, and third line is H gamma, students. Alpha, beta, gamma, delta, like that. So here, number of orbits for hydrogen atom, how many are present? Infinite number of orbits are present. Excited state, higher energy state is, that is equal to infinite. Infinite means the electron is completely removed from the atom simply. H plus electron. Sodium is there, Na plus electron. This electron is completely removed. In this energy level, the energy of the electron is 0 simply. N is equal to infinite means completely removed. There is no nuclear force on this electron. There is no nucleus force on this electron. N is equal to infinite orbit means energy of the electron in that state is equal to 0. Okay, note, observed here the note, student. Bohr gave spectrum for 1 electron species only, like helium plus 1 electron is present, lithium plus 2, 1 electron is present. Atomic number of lithium is 3, 2 electrons are loses, 1 electron is remaining. Beryllium, atomic number is 4, after losing 3 electrons, 1 electron is remaining. So Bohr model is applicable for 1 electron species. And one more drawback of the Bohr is, Bohr not explain the ability of atoms to form molecules by chemical bonds. How the chemical atoms, that is not explained by Bohr. That is the drawback. And also another drawbacks are there. Once read the theory part of the Bohr model. Zeeman effect, Stark effect, the definitions of the Zeeman effect, Stark effect also important. Next, bright lines on dark background. This spectrum is look like bright lines. Here the bright lines on dark background. So it is a emission spectrum. Next, Bohr gave one equation for calculation of lambda of spectral lines of hydrogen spectrum. Here this is the first line, this is the second line, this is the third line. Every line here, if you notice that this is the energy gap between first orbit and second orbit. This is the energy gap between first orbit and infinite orbit. Energy gap is increases. You know that already. Energy increases, frequency increases, wavelength decreases. Wavelength decreases. Now tell me, H alpha line and H beta line. Very important. It is very important. H alpha line and H beta line. Which line have the more energy? H beta line, because of energy gap is more, frequency is more. H alpha line, H beta line. In the every series, first line have more wavelength. last line has less wavelength in every series. First line has more wavelength, last line have less wavelength. That is very important in the problems also. Next, what is the for calculation of wavelength? For every line, Bohr and his co-workers gave one equation for calculation of lambda or frequency. Bohr gave one equation for calculation of lambda of spectral lines of hydrogen spectrum, that is nu bar is equal to 1 by lambda is equal to RH Z square 1 by N1 square minus 1 by N2 square. What is N1? Lower orbit. Here the N1 is the lower orbit, N2 is the higher orbit. RH is the Rydberg constant. That Rydberg constant value 1,09,667 centimeter inverse. This equation units are centimeter inverse. So different expressions are there. 1 by RH is equal to 912 angstroms. These expressions are important for RH. And one more point, Rydberg constant is different for different atoms. Remember this, Rydberg constant RH value is different for different atoms. Hydrogen and hydrogen-like spaces, this is the value. Hydrogen and hydrogen-like spaces. That means for 1 electron spaces. Bohr gave only this spectrum for 1 electron spaces, not for multi-electron spaces. Why? Because if electrons are multi, these lines are not a simple lines. They are observed is like a broad lines, that the merged lines are wedging to each other. So simply this spectrum is possible only observation for 1 electron spaces.